Welcome to this special Ask Me Anything session with the Dr. Gaurav Sethi, head of School of Electronics and Electrical Engineering, lovely professional university. So I'm your host again, Dalvinder Kaur from lovely professional university. So let's dive into today's topic, electronics, robotics, IoT, or VLSI. So, our today's expert, Dr. Gaurav Sethi, he's having over 20 plus years of experience in teaching and research. His expertise lies in biomedical image processing, computer vision, and more. He has published over 30 research papers in national and international journals, contributing significantly to his field. Before we proceed further in today's session, I would like to request everyone for any questions. You can write in the chat box or in the Q&A box, and same will be just from my side. Now I'm going to hand over this session to our expert, Dr. Gaurav Sethi, and it would be an absolute delight to listen from him.
Thank,
Over to you,
thank,
Dr. Gaurav Sethi.
thank you so much, ma'am. Thank you. Good afternoon, everybody. I am Dr. Gaurav Sethi, and I am head of the School of Electronics and Electrical Engineering. Let me tell you a little bit about the school. So, under the aegis of School of Electronics and Electrical Engineering, we offer a lot of undergraduate, postgraduate, and PhD programs. So, let us start with the undergraduate programs. We offer BTech 4-year undergraduate program in Electronics and Communication Engineering. Then we offer BTech in Electrical Engineering, BTech in Electrical and Electronics Engineering, BTech in Robotics and Automation Engineering, BTech Robotics and AI, BTech Semiconductor Chip, BTech ECE specialization in Semiconductor Chip Design. Then the last one is BTech 3+1 program, means 3 years you will study here and 1 year you will study in the partner university in US. So these are the undergraduate programs that we offer in School of Electronics and Electrical Engineering. Then I'll shift to the postgraduate programs. So we offer a couple of postgraduate programs also. So let me start with the first program, that is MTech in Electronics and Communication Engineering, MTech in VLSI, MTech in Power Systems. Then the PhD programs. So for all undergraduate programs that I told you, we offer PhD programs also. So these are the broadly 3 categories of the program that we offer in School of Electronics and Electrical Engineering. So along with these programs, we lay a lot of emphasis on the curriculum of our school, that is School of Electronics and Electrical Engineering. So we call it as SEEE. So the abbreviation is SEEE. So we lay a lot of emphasis in SEEE for industry collaborated programs. Means we take a lot of feedback while we design our curriculum. We take the feedback from the industry so that there is a smooth transition from the university to the industry, because we want to know what industry wants from the engineering graduate. Then we inculcate those courses, those topics, those softwares in our curriculum, so that our students find it very easy to transfer, to go from, the transition from the university to the industry. That becomes much more smoother as far as LP students are concerned. Then we take a lot of feedback from our alumni. We take a lot of feedback from the current students. See what are the what feedback they'll give. So whatever feedback they'll give, wherever it is feasible, we'll incorporate those feedbacks, and then that is the protocol by which we design our scheme. So that is broadly how we design our scheme. Then the another vertical, one is the curriculum design, another vertical is the education revolution. So what is it? See, Lovely is pioneer in every field. We are pioneer in placements, we are pioneer in search. Right now there is another vertical that we aspire to be pioneer with, that is education revolution. We want to bring the revolution in the education. How? By doing a lot of things. The first and the foremost is by encouraging students to go outside classroom for different activities. For example, we arrange a lot of hackathons. Now, what is hackathon? Hackathon is nothing but it is a competition, technical competition, wherein we'll give the problem statements to the students and we'll give them 48 hours. They will work day in, day out for next 48 hours, and they will come up with the project. And based on the project, based on the evaluation of that project, we'll give them the marks. It is not the conventional kind of, the evaluation, pen and paper evaluation. No, it is the evaluation that will give them the practical exposure. So how the performance of the students in hackathon, how they defended their project, what project they have made, what is the contribution of the project in the society, based on these parameters we evaluate them. So that makes the, the study very interesting. We are taking the students outside the classroom. That is one part of the education revolution. We encourage the students to have a lot of MOOCs. Now, what is MOOCs? MOOCs is, the online resource available for different platforms. So students can go, for example, the NPTEL. It is the MOOC which is governed by the government of India. So they have been asked to go and register in the MOOC. They will attend the online classes. They will, the government will evaluate it. The NPTEL means the government portal. They will evaluate it. The students have to come back with the certificate and will give them the credits. So the whole endeavor is to give them the credits outside classroom, so that they will be more exposed to the practical exposure. They will be more exposed to the things which are, available outside classroom. So that will make our students more employable. So that is the whole idea of education revolution. So this is, some of the things, some of the highlights that I've told you. There are many highlights that I can talk about, but this session is not about what I am telling you. This session is more about what you want to ask. So this house is open for the question and answer. So you are invited to ask questions in the chat box, and I am happy to answer your questions. Over to you, ma'am.
Thank you so much, Dr. Gaurav Sethi. So Gurpreet Kaur is with us. Gurpreet is asking, what are the main components of a robot and what role does each component play?
Okay, so see, robot is a complex entity, but I'll tell you, broadly in layman's language, there are three verticals of a robot. One is the sensor. The another one is, no, rather, I'll come back again. There are two parts in which we can divide the robot. The one is the tangible part, which is the hardware. The second one is the non-tangible part, which is the software. So I'll discuss the tangible part first. The tangible part is the hardware, which is sensor. Now, what is sensor? Sensor is a device which converts the physical quantity to the electrical signals, because the robot understands the language of electricity, electrical signals. So the first part is the sensor, which sense, for example, I want to pick the phone. The sensor must tell me that is it hot or what is the temperature of this phone. So that I can guess, the robot, I can guess with my brain, but robot can guess with the help of the sensor. Fine. So the first part is sensor. Then the next part is the motors. For example, this is my hand. This is the movement of my hand. So how can I do it? With the help of the motors in the robot. Fine. So that is the second part of hardware. The third part is actuators. So the three verticals, these are the tangible part, the hardware. The non-tangible part is the software, wherein you need to have the operating system. Likewise, this mobile has the operating system. Now we do have the robotic operating system, ROS, means the system which tells, the software which tells the robot to take decisions. So these are the categories. There is a lot of detail that I can go in, but to summarize, there are basically two parts, the hardware and the software. I hope I answered your question.
Yes, I hope Gurpreet, you got your answer from our today's expert, Dr. Gaurav
In
Sethi.
case you have some other query, you can always ask again.
Yes. So Neha is with us. Neha is asking, what is the function of a capacitor in an electronic circuit and how does it behave in ACs versus DCs circuits?
See, the function of the capacitor, it is different for different application. Broadly saying, the capacitor is used to store energy. That is the basic part. It stores the energy it in one cycle and then it releases the energy in another cycle. For certain applications, the capacitor is used to block the energy for some time also. For example, you want to delay the signal. You want to delay the signal. What you will do, you will charge the capacitor for some time, and then it will take time to discharge. So that means it stores energy, then it releases energy. It takes time. So it can be used for holding the energy, or because it holds energy, it delays the signal. You understand? Then it is used for the second part of the question is that how it behaves for AC and DC. See, it blocks the DC, it allows the AC. That means wherein you want to block the DC signal, you can use the capacitor. Why it blocks the DC signal? Because the resistance offered by the capacitor, it is inversely proportional to frequency.
The difference is
So for DC, frequency is 0. The resistance offered by the capacitor is infinite. That means it blocks the DC. So for AC, it allows the signal to pass. For DC, it blocks. So that is the whole idea.
Thank you so much, Dr. Gaurav Sethi, our today's expert. I hope, Neha, you got your answer from our today's expert. So, Radhika Sharma is with us. Radhika is asking, describe the differences between analog and digital signals with examples.
Okay. So see, analog signal, basic, basic analog signal is a signal which varies with time, like this, something like this, sine wave. Likewise, I'll give you the example of the sine wave in real life, human behavior. It varies with time. When I'm happy, I behave differently. If I am sad, I behave differently. You know, that is this sign means the variation in the behavior, it is analog signal. Now, what is digital signal? Wherein there will be only finite variations. Fine. In analog signal, there will be infinite variations, but for digital signal, we are having finite variations. And where is the application? In real life, I told you the application in the human behavior. In technical part, the analog signal, like your radio, that is AM signal, FM signal. Frequency modulated FM signal is the example of analog signal. But the example of digital signal is, it is the data flowing within the computer. When you are attaching your pen drive, when you are attaching your pen drive in your computer, the data transfer takes place. It is what? It is digital transfer. Right? The direct to home, the signal coming to your DTH, your dish, converts the signal into the digital, and then you can see it. So this is the example of digital signal.
Thank you so
I
much,
hope
our
I
today's expert, Dr. Gaurav Sethi. I hope, Radhika, you got your answer from our today's expert. So now Supreet Kaur is with us. So Supreet is asking, what are the main types of semiconductors and how do they differ in conductivity?
see semiconductor. I'll tell you what is semiconductor. If you divide the name, it is semiconductor. Somewhere the conductivity lies between insulator and a conductor. What is conductor? The electricity flowing through the wires is conductor. Now, what is insulator? Your rubber is your insulator. Your chappal that you are wearing is insulator. The conductivity of the insulator is very low. The conductivity of the conductor is very high. The conductivity of semiconductor lies in between. There are many types of semiconductor. It all depends upon the kind of doping that you are giving to the conductors. You might have heard the silicon and the germanium. Broadly, we are using these two, the silicon and germanium. So how do we divide the semiconductor in two categories, silicon and germanium? It depends upon the valence band, the valence electron. You understand? In one part it is 3, another part it is 5. So there are broadly two types of semiconductors, silicon and germanium. Based on it, N-type and P-type. One is donor, another one is acceptor. Fine. So that is, I hope
Thank you
I
so
answered your
much.
question.
Yeah, Supreet.
Again, I am
I
requesting to the students, just a minute. Again, I am requesting, in case you still have doubt, once I answer your
yes,
query, still you have doubt, you can ask the follow-up question also.
yes. I
Because
hope
I
this.
am assuming that you all are in +2. So I am trying to give answer in the language and in the complexity that you can absorb, that you can understand. I am not inclined to get into the micro details You may not be familiar with the terminology. That is why I am giving the answer, which I think that you can understand. In case you have any doubt or you want to ask a follow-up question, you can always ask. Yes, ma'am.
Yes, yes. Thank you so much, Dr. Gaurav Sethi, our today's expert. So, Preet, I hope you got your answer from our today's expert. So, Ravi Galyan is with us. Ravi is asking, how do ultrasonic sensors work in obstacle detection for robots?
Now, before I come to the ultrasonic sensors, ma'am, is it ultrasonic? I have heard it right, I hope. Ultrasonic.
Yes. Yeah.
Okay. So first, what
Yeah.
is the concept of, the obstacle detection? So the sensor is used to see the obstacle. For example, this is the obstacle and this is your device. So with the ultrasonic sensor, the ultrasonic sensor emits the frequency. Once it emits the frequency, it strikes with the obstacle and then comes back. You know the frequency, you know the time period, and with the formula, you can find out the distance. You understand? V is equal to F lambda, or V is equal to F maybe D or whatever. Fine. So you know the frequency, you know the velocity, or you know the time period, you can find out the distance. This is how it works. So it emits the radiations, it strikes with the obstacle, comes back, you know the frequency, you know the time period, then by the formula you can find out the distance. This is how it identifies the obstacle, that okay, beyond this distance, okay, after this distance there is a obstacle.
Yes, thank you so much. I hope, Ravi, you got your answer from our expert, Dr. Gaurav Sethi. So, Gaurav Sethi is with us. Jaspreet Kaur is with us. Jaspreet is asking, what are the key layer for an IoT architecture and what is the function of each?
Okay, so before I go to the IoT architecture, rather we have to understand what is IoT. IoT is Internet of Things. That means the things are talking to each other via a cloud. You understand? Fine. So there are, multiple layers. The first one is the sensing layer, because you have to sense it. Fine. Then the network layer. The another one is the network layer. Then once you pass the network layer, then we have the middle layer, that is processing layer. And then finally, what is the application? Fine. So it starts with the sensing, then the network layer, then the processing, then the application. So these are broadly the layers of the IoT. So these layers, work together. They acquire the data, process it, transfer to the other layer or maybe the other device. Then that device process it, and then based on the application, you can see the results and then you can infer it. That is how it works, particularly to find the business solutions.
Thank you so much, Dr.
Yes,
Gaurav
ma'am.
Sethi. I hope, Jaspreet, you got your answer from our today's expert.
I'm very
So,
happy, ma'am.
Ankush,
I'm very happy that the students, they are asking very very good questions, very technical
yeah.
questions, and that gives me the encouragement, the motivation that the students that will get, they are really interested in the electronics, maybe robotics, electrical or something. So that is a good thing. That is a good
Yeah,
omen.
let's move to the next question. Ankush is with us. Ankush is asking, how does a smart sensor differ from a traditional sensor in IoT system?
So I'll give you one example. The difference between smart sensor and traditional sensor is the difference which is in the conventional student and the smart student. Now what is it? The basic idea is that the smart sensor can take the data and then process it and then take the decision, but the conventional sensor can take the data but it cannot take the decisions. So that is the whole idea about the smartness. You understand? That is the whole idea about the smartness. Gather the data, process it, understand it, and then take the decision. That is the smartness of the sensor. Take the data, pass on to the different the subsequent layer, that is the work of the conventional sensor. So the difference lies in the application. Yes, ma'am.
Thank you so much. I hope Ankush, you got your answer from our today's expert, Dr. Gaurav Sethi. So now Prashant is with us. Prashant is asking, what is the role of cloud computing in IoT, and what are the some popular platform used in this?
See, now what is cloud computing? General layman language. See, what is cloud above our head? Fine. Now, what is cloud computing? A server or the infrastructure which takes the data. For example, this is one mobile. This mobile wants to talk with the Siri, or maybe Siri, or maybe Amazon. What is it? Amazon Alexa, for example. Now that these two cannot talk to each other directly. So what is it? This mobile will send the data to the cloud. The storage. Cloud is basically the storage capacity, the infrastructure which is given. The protocols are there in the cloud. Fine. The cloud will then send the data to the Alexa. Okay, this mobile wants to talk to you, and that is through cloud, through internet. Fine. So basically, the cloud is the storage infrastructure. Fine. And it is used as basically intermediate layer which takes the data from one device, process it, and then transfer it to other data. So that is the whole idea. Now, what was your second question? Yeah, okay. Different type of cloud. So it is, different companies have different names. For example, the Microsoft Azure, the Amazon having different server, the IBM having maybe Watson or different server. Fine. So every company is having different cloud server. I gave you some example for Microsoft. One of the most famous one is the Microsoft Azure. So likewise, Amazon has, the IBM, maybe the different kind of, because it is a lot of private players are involved in it. But the government of India, they are setting up a lot of data structures data centers in India now. So that is the whole idea. Yes, ma'am.
Thank you so much, Dr. Gaurav Sethi, our expert. I hope Prashant, you got your answer from our today's expert. Can we take the next question, Dr. Gaurav Sethi?
Yeah, sure, ma'am. Sure, I'm ready.
Yeah, thanks for giving me chance to
It is
address
not.
your many questions to our expert, Dr. Gaurav Sethi.
It is
Yes.
not showing in my chat box. Anyway, you
Yeah,
can.
I'm going to address the next question. Yeah, Dilpreet is with us. Dilpreet is asking, what is the difference between ASIC and FPGA in VLSI design?
Okay, before coming to the difference, the VLSI is layman language again. Very large scale integration means when you are putting everything in a small chip. See, how can you make a mobile lighter and cheaper? How can you do it? By making this mobile in a miniature form. That is the whole idea. So VLSI is the technology that can putting everything on chip. Fine. Now, what is AISIC? ASIC is a integrated circuit, application specific. The name is application specific integrated circuit. So, as the name suggests, it is the integrated circuit, the chip, which is application based. Means it is used for a particular application. You understand? But the FPGA it is field programmable. Means it can be programmed differently. You understand? It can be programmed differently. So broadly, the basic idea is the FPGA, the ASIC is the application based integrated circuit, and FPGA is you can program it again and again. That is the whole idea.
Thank you so much, Dr. Gaurav Sethi. I hope, Dilpreet, you got your answer from our expert. Someone is asking here, what are the major steps in the VLSI design from specialization to layout?
Okay. See, basically, again, it is again divided in two parts. The one is the designing, which includes the simulation also. The another part is the implementation on the chips, which is known as fabrication. So broadly two parts: non-tangible, non-tangible, and tangible. Now the non-tangible is it starts with circuit design. So you know the application that okay, this is the circuit that I want to you know fetch in my chip. You understand? So it will start with the design. I have the circuit with me. I need to design it. Then I need to verify the design that okay, how can I verify it? Using simulators. Verifying means implement everything what do you want to implement in your chip on software on computer so that I can able to see that means whatever is the output I want to get I am getting the same output because once I put everything in my chip then it create a problem then it will not be very cost effective. So implement everything on whatever I designed, implement on simulator. The second part is to simulate it, means to verify the design. Third is to write that program in the chip. You understand? Write the program in the chip. So what is it? That is again very costly affair because that needs the crores and crores and millions of dollars of the investment. That is very sensitive process. Fine. So the steps are design, see, design the circuit, verify the circuit, check the circuit, implement the circuit, write that program in your chip, which is known as fabricate the chip. So these are broadly the stages of chip design. Then last one is testing. Finally, once you design a chip, you implement everything on chip, you have to test it physically. So that is the last part.
Thank you so much, Dr. Gaurav Sethi. I hope all the participants got the answer from our today's expert, Dr. Gaurav Sethi. If anyone have any questions regarding the admissions, they just write on us at admissions@lpu.co.in. You can do WhatsApp chat with us. Our WhatsApp number is 985256900. I'm repeating the number. It's 985256900. And once again, thanks to our expert, Dr. Gaurav Sethi. As we come to the end of this AMS session, I want to express my deepest gratitude to our experts for sharing their valuable insights and expertise with us. Your presence, enthusiasm, and active participation have made this experience truly special. Hopefully, the attendees found this AMS session to be valuable and will be able to utilize the information for better decision making regarding admissions. If anyone wants to assess this session again, they can visit our website that is lpu.in or can be assessed on YouTube also. Stay connected with us for future AMS sessions until we meet again. With the permission of my seniors, I would be signing off this AMS session.
Thank
Take
you
care
so
and
much, ma'am.
goodbye. Have a
Thanks,
beautiful
everybody.
day. Thank you. Thank you, Dr. Gaurav Sethi. Brilliant.